A new business began tracking how many customers entered the store each week. If the trend continues, during which week will 156 customers enter the store? Okay, does anybody think they have the right answer? Okay, what'd you get, Xavier? What? B is correct, week 8. Okay, how did y'all figure that out? Xavier? Okay, so there was a pattern, a trend. It's not linear because it's not adding the exact same number every time, but there is a pattern you could look at. First, from week 1 to week 2, it was an increase of 12 customers. Then from week 2 to week 3, it increased by 14 customers. Then from week 3 to week 4, it was an increase of 16. And then from week 4 to week 5, it was an increase of 18. So what you would have to do is just continue that pattern. And so most of you probably just sat there and typed in your calculator. 6, 7, 8. Okay, if it's jumping up by 2, the next increase would be by 20. And so 90 plus 20 is 110. And then the next increase would be by 22, and that would bring us up to 132. And then the next increase would be by 24, and 132 plus 24 is 156, which is what we were trying to figure out when that many customers would enter the store, and that occurred at week 8. Does that make sense to everybody? All you had to do was be able to recognize the pattern and then continue it out until you got to that number for your Y value. Okay, now today we are going to start filling out that flip book in your notebook. Okay, yesterday we went ahead and wrote down today's essential question. It's how are rates and unit rates used in the real world? And today we're going to start filling out some of this book, not all of it. It'll take us probably a few days to fill out, but we're going to start it today. Scissors? Yeah, they're right back here. Okay, does everybody have this flip book out and ready to go? All right, so when you open it up, we'll be starting with this page. Now let me zoom in some. All right, a rate is a special kind of ratio where the two amounts being compared have different units. For example, you might use rate to compare 3 cups of flour to 2 teaspoons of sugar. The units, cups and teaspoons, are different. A unit rate is a rate that has 1 as its denominator. To find a unit rate, you're going to set up a ratio as a fraction and then divide the numerator by the denominator. Okay, so the important thing to remember is that a unit rate will always have 1 as its denominator. Okay, now let's try some examples. All right, example 1. A car can travel 300 miles on 15 gallons of gasoline. What is the unit rate per gallon of gasoline? Well, remember on the previous page, it said that we needed to set up the ratio as a fraction and then divide. So we need to take 300 miles and set it up as a fraction, so put it over 15 gallons. And then you'll just divide it. What is 300 divided by 15? 20. Now remember, it also said with the unit rate, the denominator is also always a 1. Well, isn't this technically 20 over 1, even though you don't have to write the over 1? Okay, so it's 20 miles per gallon is the unit rate for this car, how much this car can travel. All right, example 2. Jacob pays $1.60 for 2 bottles of water. What is the unit price of each bottle? Okay, well, he starts out paying $1.60, but that's for 2 bottles of water. So if we divide that, you get what? 0.80, and isn't that 80 cents per bottle? All right, example 3. An athlete can swim half a mile every 1/3 hour. What is the unit rate of the athlete? Okay, yes, this one looks different because we're dealing with 2 fractions. But if you just continue doing the same procedure that we did on the previous 2 examples, you're going to get it right. So what do we need to do? What did we do on the previous 2 examples to simplify it? What operation? Division. Okay, so it's just half a mile divided by 1/3 of an hour. Okay, now let's talk about how to type that in the calculator. Okay, the whole thing is one big fraction, right? It's a fraction with a fraction as the numerator and a fraction as the denominator. So this is how you would type it in. You would hit alpha y equals, and it will pull up this little box. Okay, does everybody see that little box? And when you hit alpha y equals, it's the very top left button. Okay, alpha is the green button, and then you'll hit y equals, which is right here. And it should pull up this little box. Okay, now see how that first option is n/d? That's numerator over denominator. So that's to set up a fraction, so you hit enter. Now, isn't our numerator also a fraction itself? So now that you're in the numerator, you need to make it a fraction again by doing alpha y equals n over d. What is the fraction in our numerator? So 1, and then arrow down, and 2. Now you can arrow down to get to your denominator. So has everybody been able to successfully do what's on the screen? Okay, now isn't the denominator also a fraction? So you need to set up for a fraction. Alpha y equals n over d, which is number 1, and then type in your fraction 1/3. And then you just hit enter and you get 3/2. Now, let's talk about how to make that a decimal. If you hit alpha y equals again, look down at number 4. F to d means turning a fraction into a decimal. It'll also work the other way around. Like if you're in decimal form and you want a fraction, you can also use this same one. So hit number 4. And then you also will have to hit done, which I think mine just froze up. Okay, when y'all hit 4 and then you hit enter, what does it say on your screen? 1.5. Okay, so this equals 3/2, which we know is 1.5, and that would be miles every hour, or you can just write that mph. Okay, now that was quite a bit of work, right? That was a lot in the calculator. So let me show you something different that you probably remember from middle school. Do y'all remember your middle school teacher ever saying keep it, change it, flip it? Okay, what they mean is you keep the first fraction the same. You're going to keep it as 1/2. But instead of dividing by another fraction, we're going to change it to multiplication. And then to be able to do that, you have to flip it, which means take the reciprocal of that fraction. The reciprocal of 1/3 is 3/1. Reciprocal means you just flip it upside down. And so now we've kept the 1/2, we've changed the operation of multiplication, and we flipped the second fraction. Now this is easy. You don't even really need a calculator to multiply. You just multiply straight across. 1 times 3 is 3. 2 times 1 is 2. And now you have the same thing that you got, but just a lot less work than typing all that in. Now, say that you get that and all the choices on your test are decimals. You can literally just, oh, mine still froze. You can literally just type in 3 divided by 2, enter, and it'll say 1.5. Okay? All right, example 4. If a student makes 450 mistakes in 9 tests, and we're going to assume that they're consistent and they make the same amount of mistakes per test, which I know is not realistic, but we're just going to assume it is. How many mistakes are made per test? You would take the 450 mistakes made on the 9 tests, and that would simplify to how many mistakes per test? $50, because isn't 50 over 1, but you don't have to write the over 1? So 50 mistakes per test. Okay, now let's turn to the next page where we're going to find unit rates from graphs and tables. All right, example 1 says find the unit rate. Okay, well, to find the unit rate of a linear function, all you need to do is pick 1 point. Now, keep in mind, with a unit rate, we want the denominator to be what? 1. So we need to pick an x value of 1. Well, if you go on this graph, can you find 1 easily? Can you find 1 easily on the x-axis? No, because it goes from 0 to 15, so 1 would be like way back here. It's going to be kind of hard to figure out the y value of that, correct? So instead, you want to just pick a nice point, maybe something like this one, which is over 15 up how many? 360. Okay, now your goal is to simplify that so that you will have a denominator of 1. So you do 360 over 15, and what does that become? 24 over 1, or just 24. So it's 24 points per game. Now, it wouldn't have mattered what point you chose on that. Because it's a line, you would have gotten 24 no matter what point you picked. Okay? All right, now let's look at example 2. Find the unit rate from a table. Okay? All you do is you take a y value and divide it by the x value. Okay, Xavier, you want to? Okay, so just pick a y value, one of the y values. Okay, if you pick 400, you would need to divide it by its corresponding x value, which is 100, and that gives you 4. Isn't that $4 per square foot? And it wouldn't have mattered if you had picked another x and y value. You would have got 4 for all of them. 100 divided by 4 is 25. 100 divided by 25 is 4. 1600 divided by 400 is 4. 6400 divided by 1600 is 4. So, since all the points are like that, since all of them give you a 4, wouldn't this table also make a straight line because it has a constant rate of change? Every single rise over run gives you 4. All right, example 3. The formula for mass equals density times volume or the formula for mass equals density times volume. What is the unit rate for density if mass is measured in kilograms and volume is measured in m cubed? Okay, so we're going to change everything. Like, what did they tell us mass is measured in? Mass is measured in kilograms. So instead of rewriting mass, we're going to write kilograms. And then what did they tell us density is measured in? Did they? No, they want us to figure out the unit rate for density, so we don't know what it is. We just leave it D for density. And then times volume, which they told us is measured in, right. Okay, but now to figure out, oh, there's another typo right there. To figure out the unit rate for density, you would need to get density by itself. How can you get this D by itself? Guys, how would you get D by itself? To get something by itself, doesn't everything else need to move away from it to the other side? So what needs to move away from it? The m cubed. Aren't they currently connected by multiplication? So how do we undo that? Divide, because you want to do the opposite. So we divide by m cubed, leaving D by itself like we wanted. But since we divided by m cubed on this side, you also divide by it on this side, and so you end up with this. Okay, now we're going to practice some of these problems in your packet. So go ahead and get out your new packet that I gave you and turn to page 1. All right, number 1 wants us to figure out the unit rate from this graph. Now, since it is a linear function, it's a straight line, it doesn't matter where we pick the point because it would be the same no matter what. Now, like I said though, with a unit rate, you want your denominator to be what? 1. So if you're able to pick the point that already has an x value of 1, that will work out nicely for you because you won't have to do any kind of simplifying. What is the corresponding y value for this? 20. So that's 20 points per gain is the unit rate for this graph. All right, number 2, for this one, are we able to pick a point with an x value of 1? Yes, even though it's not numbered, we know that 1 would be right there, and its corresponding y value is 10. So that's $10 per hour. All right, what about number 3? Can you pick a point at x equals 1 for this one? You can. You just better be careful if you do to make sure you have the right y value. What's the y value? 15. Because if you look, it starts at 0. So this would be 5, 10, 15. So that's 15 words per minute. All right, number 4. For this one, are you able to pick a point at 1? No, it would be a little harder to figure out the y value. So let's pick the point at 2. If we go over to 2 on the x-axis and then we go up to the line and draw a point, what is its corresponding y value? 150. So you have the point 2 and then 150. And if you do 150 divided by 2, you get 75, and that's miles per hour. All right, number 5, where would be a nice point for this one? 10 and 5,000, and so you do 5,000 divided by 10, and that gives you 5,000 divided by 10, $500 per year. All right, number 6. Where is a good point for this one? Nice point. Okay, so you go right 1, up 150. That would be 150 over 1, so 150 beats per minute. All right, number 7. Where would a nice point be for this one? 2 and 80 would work. Okay, or 1 and 40 could have even worked. So now that I've said 1 and 40, that pretty much tells you the unit rate is 40 sit-ups per minute. All right, number 8. Okay, where would a nice point be for this graph? 6 and, so what's the Y value of that? What's right in between 120 and 240? 180. Now, if you have trouble figuring that out, just pick another point, like 12, and what is that up there, 360? Okay, and so what is 180 divided by 6 or 360 divided by 12? What? 180 divided by 6. 30. So it's 30 gallons per hour. All right, and then number 9. What would be a good point to pick for this one? Can you pick a point with an X value of 1? Yeah, you can. It would be right there, but you got to be careful figuring out what Y value this would be. What would that be? What are they going by? What are the intervals? Right, they're going by 5, so this is 25. There's 25, 30, 35, 40, so it's $25 per hour. Okay, now we're going to skip page 2 and go ahead and look at page 3. All right, number 1, this time we're going to be finding the unit rate from the table. If you look at the table, the first X value has a Y value of 10, and then 4 with 20, 6 with 30. So you can see that all of them have what rate of change? As you jump by 2s, the Y's are jumping by 10, and 10 divided by 2 is 5. Now, since we see that it's constant rate of change, that means that if you plotted these points, they would also make a straight line. This is a linear table. All right, number 2, same thing with it. 4, 40, 8, 80, 12, 10. The X values are jumping by 4, while the Y values are jumping by 40. So 40 over 4 is 10, and that's $10 per ticket. Number 3, this time you have a jump of 3 to 13 and 13 to 16, so they skipped some numbers. So let's try a couple. What's 60 divided by 3? 20. What's 260 divided by 13? Okay, and then is 320 divided by 16 also 20? So is this linear? Yes, it still is. It's just they skipped some of the points in the table. Okay, they probably should have gone 3, or no, that wouldn't have worked. This is jumping by 3. But we can still say, because of the info they gave us, that it's 20 points per game. All right, number 4. The X's are jumping by what interval? 5s, and the Y's are jumping by 40. So 40 divided by 5 is 8, so 8 inches per year. Okay, number 5. The X's are jumping by 40s, and the Y's are jumping by, okay, let me just confirm that for the second one. Okay, 360 plus 360 is 720. And then if you add 360 again, it takes you to 1080. So yes, they're jumping by 360. And 360 divided by 40 is, right, so $9 per hour. Okay, now let's go on to page 4. Okay, everybody turn to page 4. All right, Stefan loves playing basketball. He comes up with a plan to work on his free throws every day until the season starts. He's going to shoot 100 free throws every day for the next 12 weeks. How many free throws will he shoot over the next 12 weeks? Okay, so what's the important information here? 100 free throws, and that's every day for the next 12 weeks. So what do we need to do to figure out how many he'll shoot over the next 12 weeks? If he shoots them every day, isn't that 7 days a week? So it'd be 100 times 7, which means he's shooting 700 every single week, but he does that for 12 weeks, so wouldn't you multiply all of that by 12 as well? And that gives you what? Right, 8,400 free throws. Okay, number 2. Miss Merrill wants to buy donuts for her homeroom students as long as all the students return their info cards and receipt of information form. She has 21 kids in her homeroom. She knows she can buy 12 donuts, so a dozen basically, for $3.99. She wants each kid to get 2 donuts. So, what do we need to figure out first? It says, how much do you expect her to pay for donuts? Well, how many donuts does she need? Right, she needs, what'd you say? 42 donuts. And why does she need 42 if she only has this many kids? Right, she wants each of them to get 2. So 21 times 2 is 42 donuts. Now, she can buy a dozen donuts for $3.99. But if she wants 42 donuts, how many dozens does she need to buy? What's 42 divided by 12? 3.5. So at the price of $3.99, how much would that cost her? $13.97, right? Is this number reasonable? Can you buy a fraction of a box of donuts? Can you always buy a half dozen everywhere? No, not always. Okay, you can't just buy 3.5 donuts or boxes of donuts. So, for her, say she's at a store that only sells them by the dozen. How many boxes would she need to buy so that she has 42 donuts? Or at least 42? 4. If she goes ahead and she buys 4 dozen donuts at 12 donuts each, yes, that will give her 48, which means she's going to have some leftovers. And at $3.99 a dozen, that will cost her how much money? How much money would 4 dozen donuts cost her? $15.96. Okay, but remember, she doesn't really need 4 dozen because she only needs 42, and 4 dozen donuts is 48 donuts. So, say she was at a store that would sell her 6 donuts for $2.49. Would she be better off doing that? Okay, well, let's see. If she bought 6 donuts for $2.49, that's that much money. And then she would need to buy how many dozens at that price? Remember, this amount's going to get her 6 donuts. So she needs 36 more donuts, which means she needs 3 more dozen, right? So 3 at the price of $3.99 each. What does that become? Remember, this $2.49 is going to get her 6 donuts, but she needs a total of 42, so she needs 36 more. 36 donuts is 3 dozen donuts. At the price of $3.99 each, how much does that become? You just type it in, 249 plus 3 times 399. And what do you get? 14.46. So is that the best deal? If she only wants 42 donuts? Yes, that's the best way to go. If they offer half dozens at that price, that's the best way to go. All right, number 3. As Felicia gets on the freeway to drive to her cousin's house, she notices that she is a little low on gas. There is a gas station at the exit she normally takes, and she wonders if she'll have to get gas before then. She normally sets her cruise control at the speed limit of 70 miles per hour, and the freeway portion of the drive takes about an hour and 15 minutes. Her car gets about 30 miles per gallon on the freeway, and gas costs $3.50 per gallon. Describe an estimate that Felicia might do in her head while driving to decide how many gallons of gas she needs to make it to the gas station at the other end. All right, this is quite a lot to do in your head while driving, but we'll give it a shot. We know she goes 70 miles per hour. So, how many miles will she drive in an hour and 15 minutes? Anybody figure that out? That's very close. Yeah, I mean, if you were doing it in your head, that's a very good guess in your head. But, okay, 70 miles per hour. Obviously, in the first hour, she's going to make it 70 miles. So it's going to be over 70 miles. 15 minutes is what of an hour? A quarter. So couldn't we multiply 70 miles per hour times 1.25? That's an hour and a quarter of an hour. And that gives you 87.5, which is why 85 was very close. So if she goes 75 miles per hour, if she's driving an hour and 15 minutes, that's going to be 87.5 miles she's gone. Now, since we are doing this in our head, we're going to just round that up to approximately 30 miles is how long it takes to get to that exit. So now we need to figure out the gas. She gets 30 miles per gallon. So wouldn't she need to do the 90 miles she's driving divided by 30 to figure out how many gallons she needs? And that's how many gallons? 3 gallons is how much she needs in her tank to be able to drive 90 miles pretty much. Okay, well if it costs $3.50 per gallon, how much money will that cost her? Approximately $10.50. Now, had we not rounded it up to 90 and we'd have gone with exactly 87.5, it would have been $10.21. But remember, this is while driving, so we're just going to approximate. All right. We are going to stop there for today. Your homework is to do page 2 and 3, and we still have 8 minutes, so I would go ahead and try to get it done now so that you don't have to do it tonight. So page 2 and then finish page 3 is your homework.